Let's talk about complexity and abstraction in programming and why I think that it's one of the biggest problems that we currently face within our industry. And this problem has obviously been increased by the usage of AI coding agents, where we want to hide all of the complexity related to what we're doing, and we end up shooting ourselves in the foot as a result of it. So the first thing that I can think of is that when we want to hide the complexity of something, we're not actually making that complexity go away. We're simply handing that complexity off to someone else to deal with down the line. So if you think about, for example, implementing an HTTP server, I'm not saying that you should go ahead and build your own, but if you think about this example of an HTTP server, when you use something like for example, Go library, the standard library to build an HTTP server, you're not actually running away from the complexities of building an HTTP server. The only thing that you're doing is you're relying on, in this case, the Go language team that maintains the language itself to build these things for you. And in the case of languages where maybe you import actually stuff, like let's say in the case of Rust, you import from the crates an HTTP package that handles all of that, you're just basically giving all of that complexity to another maintainer, another person to handle, and you're assuming that they're going to do a better job than you are able to do, and that's why you basically do it. Which I think that it makes sense in a lot of places to do so, but it doesn't make a lot of sense in other places. And I think that as an industry, we went too far to the other side, where now we want to hide all complexity all of the time. And again, biggest example of this is AI, where now we don't even want to write the lines of code that handles everything related to, let's say again, an HTTP request. We just want to tell the AI, hey, do this for me in English, and then we don't really care, or most of, I would say, like programmers today don't care about what happens when it comes to the code. They just want things to work, and they say they review the code, but do they really? Who knows? But the thing here is that by abstracting everything when it comes to the complexity, we lose a lot of things. So let's go over the first thing, which I don't really think this is something directly related to the quality of the software that you build, but you lose a lot of learning and a lot of lessons along the way. So if you are just importing a one-line thing where you use that to build an HTTP server, as a result, you're going to not even know what happens when it comes to HTTP itself. So for the longest time, I simply used Node.js, I used Express.js to build servers, then I tried different languages doing the same thing, Laravel, Rust, whatever. Like, I tried a bunch of different things, but only recently did I discover what actually happened beneath the surface when it came to HTTP. So the different versions of HTTP 1, 2, and 3, what that meant, what the different protocols are, and stuff like that. And granted, I don't really understand it that in depth to the point that I think I could build my own, but all of this to say that if I were to spend some time at the beginning of my programming journey to try to build one from scratch, or try to understand what it entails to build an HTTP server, I think that I would have gathered a lot of lessons that would be helpful along the way and help me build better software and figure out stuff much quickly than I would have otherwise been able to. And I think that this also then ties into the second point, which is we lose the ability to customize things and to build software that is made for our needs, for the end goal that we are trying to achieve. And I think that in this case, the HTTP server is not really a good example, but if you just leave all of the details to someone else to implement and you just use that abstraction on top of it, and usually here I'm trying to say like an abstraction that is already like very high in the chain of abstraction. So if you use an abstraction that is so high already, where you just do, for example, a line of code, a couple of lines of code, and a bunch of different things happen underneath it, you're going to encounter a lot of situations, and this is something that probably already happened to you a lot of times if you've been programming for a while, where you just are not able to fit the things that you are trying to do to the code, or actually the other way around. You are not able to fit the code to the things that you want to do. And that's because you are basically relying on the level of like implementation, or the details in the implementation of the person that did like all of the code and just gave you the abstraction. And this doesn't necessarily mean that the abstraction was wrong. It doesn't mean that it was a bad implementation of the code. It simply means that when that maintainer, either open source or someone else in your team, implemented that code, they were just thinking about the use cases that they needed, and they obviously couldn't handle in that abstraction all of the use cases possible. So when you then find a pain point that you need to fix within your code, you will find yourself a lot of times like working around the tool instead of being able to just change a small part of the code because you implemented things more, let's say, quote unquote, from scratch. And like, again, that is going to depend on what you're doing, the levels of abstraction that I think are more appropriate, but you get the point. The idea here is that if you are implementing something more from scratch, like with less abstractions, you usually gain more control. A good example of this is, let's say, Ruby on Rails. So if you use Ruby on Rails to handle a lot of the stuff when it comes to CRUD operations and building web applications, you're going to have a nice time if you stay within like the bounds of what Ruby on Rails expects. But the second that you want to do things differently than what like the maintainers envisioned, or like different than what the maintainers think it's the correct way to do things, and at that point you're going to find yourself with a lot of trouble because you will either have to work around the tool itself, so work around Ruby on Rails itself, and this is going to take a lot of time, this is going to take a lot of effort, because instead of just, again, changing that part of your code that you want to change and move on with your life, you're going to have to find all of these tricks like workarounds to be able to work around basically around the tool itself, Ruby on Rails. And this applies to everything else. So if you are using, let's say you are building a TUI, you want to build something like Cloud Code, like Open Code, a competitor to that, and instead of building all of the integrations with the terminal itself, or rather like using all of the protocols to communicate with the terminal, you use something on top of it, like let's say OpenTUI, I think that was developed by the Open Code team, or let's say that you use Ratatouille, which is a tool for Rust. If you use those packages, you're going to find that, yeah, you're going to be able to go much faster and things are going to be a lot easier for you in that sense. But then the second that you want to do things a little bit different, you'll find yourself reading the source code of both OpenTUI or Ratatouille, and you're going to find that you need to either like fork the project and change something here or something there, or you're just going to find that you're simply not able to handle all of that. Because, and this ties, I think, into my third point, which is you lose the ability itself to be able to customize your own software. Because if you get to a point where you use something like OpenTUI or Ratatouille and you already have a bunch of different features implemented that rely on those things underneath the hood, good luck with trying to understand what's happening within one of those pieces of software, because you have not written them. You need to go and read all of the code, understand all of the code, understand exactly why they did all of the things that they did, which basically means that you are, in a sense, like delaying all of that complexity. So once you start with an abstraction, but eventually you're going to get to a point where you're like, okay, I haven't implemented like the protocols to communicate with the terminal by myself. I didn't implement all those things, but I still now need to go down to that level of abstraction. And instead of relying on my code, which obviously would have taken me a lot more time in the beginning, but then I would have had this like leeway or ability to change things a lot more. Now I need to read the source code of someone else, still understand the complexity, and still not have a code base that actually does stuff in the way I intended it to do. So you're basically going to have all of that complexity plus a lot of stuff on top of it, in the sense that it's not your code base, it's not done to your particular use case, so you're still going to have to deal with the complexity. In the end, you cannot really run away from the complexity, and you're going to even have other problems next to that. And yeah, I think this is basically what I'm trying to say here and what I wanted to talk about, which is when you use abstractions in programming, you are not going to be able to ever run away, quote unquote, from the abstractions. The only thing that you are actually doing is you are hiding them, you are giving them to someone else to implement, and you're you're assuming, which a lot of times, again, I'm not trying to say don't abstract anything or just do everything from scratch, but a lot of the times the abstraction is not going to be implemented in the quote-unquote correct way, not because the programmer didn't know what they were doing, also the case sometimes, but a lot of the times is simply because they were implementing with a end goal in mind, and that's not going to be the same end goal that you have. And then when you bump into those problems, you're going to find that it's very, very hard for you to be able to like move on from all of that complexity and be able to like remove that abstraction from your code base and implement something of your own on top of it. So yeah, this is it. And my conclusion here is that even if you decide that you want to build something with some kind of abstraction, I think it's still important that sometimes you just go to the code base, you read the code base, or at least you try to understand what like the details beneath that abstraction are, what the complexities are. So let's go back to the example of the terminal. If you decide to use something like Ratatouille or OpenTUI, make sure that you actually understand what those technologies are doing, instead of just saying, oh yeah, this is like the function that renders stuff to the terminal, and you don't even know what that actually means. You just know that that function and that package handles writing stuff quote unquote to the terminal, and you don't even understand like escape codes, like the protocols of the terminal and all that stuff. So when the point eventually, like you arrive at the point where you need to change stuff, you're much better equipped to be able to handle those details of the abstraction. So yeah, this is it, and I'll see you on the next one.